Hey students, welcome back to chemistry. I'm glad that you're here. This is our first lecture and lesson we're going to have in chemistry. And as we learn chemistry this year, I'm going to be sharing a lot of my notes and lectures through this format. So if you miss a class, if there's some reason you're unable to attend school, or if you're in a situation where you might be sick or traveling, this is a way where you can catch up and keep up with chemistry. So I'll be storing these and sharing these links on our Google Classroom. So feel free to come back here as you need to. So we're going to start with our first lesson in chemistry. And chemistry is a huge part of our world. Chemistry is every part of what we do in everyday life. So when we think about something like even a spacecraft going over to Jupiter and it's collecting information and data about Jupiter's moons and the planet itself, the chemistry of the planet helps scientists study to understand the geology and even distant stars and many things that Mars, many things that SpaceX and NASA and international space agencies that are doing today with remote sensing or even having craft and rovers on Mars is to deal with chemistry and understand if there is life on Mars, is there other types of things that they can discover. It always revolves around chemistry. So what is chemistry? Why is it so big? And I think hopefully you just saw that is because chemistry involves everything. If it's made of matter, it involves chemistry. You, me, the color of our eyes, the paint on our car, the speed of this internet that I'm recording on right now, the taste of your food, the smell of your food. Everything in your life in some way throughout the day involves chemistry. So let's talk about what matter is. Matter is anything that has mass and occupies space. Another way to say that, it has volume, it has mass and occupies space. And chemistry is the study of that matter and how it changes and undergoes changes. So it studies the composition of matter, which has mass or volume, and how those may change under certain circumstances. So, because of all living and non living things are made of matter, you and I and all living things are made of matter, and non living things like rocks, um, are made of matter. Chemistry affects those. The minerals, the non living minerals that are in our body, help the living processes in our body. So all of what you go through, chemistry affects all aspects of life and actually affects a lot of our natural events. Hurricanes and storms and even climate change is affected by chemistry. So we're going to talk about today is the different areas of chemistry that we'll have, and this is what we working through this whole year. And if you think about chemistry as a career path, this is a great way to kind of chunk those into different paths for you. If you're interested in chemistry, or even a branch of chemistry as maybe your career. So there are 5 traditional study areas. There's organic chemistry, inorganic chemistry. So obviously the difference between organic and inorganic. Organic deals with things made out of carbon. Inorganic, things not made out of carbon. Biochemistry is a little bit different than organic chemistry, even though it does deal with living things. We'll talk about that in a few moments. Then analytical chemistry, and then physical chemistry. So let's talk about organic chemistry. Organic chemistry is specifically defined as the study of chemicals containing carbon. If it has carbon in it, it's considered to be organic. Okay, so what makes organic chemistry? So things like gasoline, things in your body, us breathing in and out CO2 has carbon in it. Those things are considered to be chemistry, organic chemistry. Inorganic chemistries are things that do not have carbon. So maybe the study of your bones. Your bones don't have carbon in them. So that would be inorganic chemistry. Study of rocks and minerals. The field of petrology and mineralogy in some fields of geology will use inorganic chemistry to understand how rocks have formed, its history, and how they've changed over time based on the types of chemicals that form the minerals that might be in a rock. So earth scientists, environmental scientists will use inorganic chemistry as well as organic chemistry. The study of the processes of organisms, biochemistry. So you can think of organic chemistry and inorganic chemistry coming together in the process of how those chemicals affect the processes of an organism. So think about your the blood as it goes through your system. There are many biochemical processes that use organic and inorganic compounds and molecules to help your body flow, help your body move. So your muscular system uses inorganic chemistry, electrolytes, and organic chemistry, the food that you might eat to move. Same with your respiratory system. So biochemistry, you can think of it, it uses organic chemistry and inorganic chemistry to how these functions, how your body functions, or how an organism will function. And then analytical chemistry is the study and the focus on what is in the matter. Okay, so the analytical chemistry could be more when you think of someone in a lab taking a vial or a sample of something, maybe taking a vial of blood that's right here and analyzing what is specifically in your blood. So if you've gone to the doctor, you have your yearly physical, they take some blood and they give you a report back on maybe the vitamins in your body, or your certain type of blood counts, your iron count, your cholesterol, all these different things that they'll test. They'll test your hemoglobin for in different things for your liver. So this is the analysis of a substance or the composition of what matter might be made up of. So an analytical chemist could be in the medical field. Analytical chemist could be in a forensic field where they're trying to analyze something from a crime scene, specifically what is in there. An analytical chemist could work in an environmental field where they're trying to determine what type of contaminant might be in a water or a air sample that might be taken. So analytical chemistry is using laboratory techniques to understand what is composes the matter. And then finally, physical chemistry is the area that deals with the mechanism, the rate and energy that transfers. So inside of a person's body, the physical chemistry, what's going on when you're breathing. So if you're having an asthmatic attack, what is actually happening? What is the rate, the mechanism that's happening to your body? Physical chemistry could also be what is the energy that's released when an atom is split or when they bombard atoms together to create or synthesize a new type of element, which is constantly being done. So physical chemistry deals with the rate in the energy transfer. So when you think of physical chemistry, you think about energy transfer that makes it go through a change. So there's two major, so those are the five subcategories of chemistry. And then within those fields, there might be some things that are called pure and applied chemistry, pure and applied chemistry. And the simplest way to think of that is that pure chemistry pursues chemistry just for chemistry's sake. It's just trying to understand and do experiments and do research purely just to understand why it's there. Okay. Applied chemistry then takes some of that research and is applied to a practical application. So you can think of the invention of nylon was a pure chemical pursuit where there was a reaction that a compound called nylon was created from a liquid. So this nylon that makes up your backpacks, and it may make up a tent that you might sleep in, or it might make some other, like a tarp or something that's made of nylon, that's a part of your life, was a pure chemical pursuit. Then that nylon had an applied purpose that went towards an application. So pure chemistry often will lead to applied chemistry, but sometimes pure chemistry will have tangential or other things that'll help discoveries that may later be applied. So sometimes not all pure chemistry is applied immediately, but it's necessary. So pure is just for chemistry and understanding's sake, and applied chemistry is research that is applied directly towards a goal or trying for application. So, for instance, pure research can lead directly to an application, okay? But an application exists before it explains how it's done. So here's that example of nylon in the 1930s. A chemist was looking and researching cotton and silk, and a team of scientists researched to find to commercially produce nylon. So nylon may have come out of research with cotton and silk, but out of that pure research, out of that pure chemistry became a product that is a part of most of our lives right now, particularly if you have a backpack. Aspirin. Long before researchers were looking for how aspirin works to relieve pain, doctors were finding that it prescribed it for patients who were at risk at heart attack. So it was more of a heart attack medicine. Okay, there's a heart attack medicine at first, but then in 1971, an applied application came out when a group of chemists understood that it actually blocks pain. So it was used as a pain reliever. So this is an example of pure research that led to an applied research. So when you talk about chemistry, any level of science, technology always comes in. Technology is always going to be around any level of science, and science and technology, this idea of STEM, comes in at any point. So science, technology are usually hand in hand. So technology is a means for its members of society for the things that they need. They get the things that they need. So it allows humans to do more, do some things quickly with less effort. So the fact that I'm talking on a computer screen and it's recording me, and I'm gonna upload this to a YouTube channel, and you're gonna be able to view it from any place in the world where you're at, as long as you have some sort of connection. That's technology. There are debates of whether about the risks and whether technology can be good or bad. There's unknown knowns in the sense that sometimes technology can lead to more problems. Technology can come about. The invention of the car was a wonderful thing, but it's also brought about some environmental impacts and some of our dependence upon one type of energy source, that being hydrocarbons. So there is a technology, the idea of pesticides. Pesticides have allowed us to produce food and more food to feed the world, but there are other outfalls to technology or the use of pesticides. So we'll talk about that a little this year. So technology is always related or always tied into science, particularly in chemistry. So why do we study chemistry? Why do you have to take this class this year? And there are three reasons. It can be useful for explaining our world. One thing, as we're pursuing the understanding of God created our world, we want to see why is it the way that it is. So one way is it explains our world, preparing people for those career opportunities that chemistry might be a part of your opportunity. You might be not directly involved. You might be a day trader one day, but chemistry in the market that goes around what the special precious metals that goes into phone that may drive the market, the commodities market that you might be as a stock trader, is affected by chemistry. The fact that you might be in construction, the use of materials in construction, be it wood or whether it is concrete or a new type of concrete that can cure faster and stronger, and have the ability to withstand different weathering conditions, revolves around chemistry. If you're in the medical field, obviously prescriptions and drugs and understanding of different types of medicines and how they affect the body is chemistry. If you're a cook, if you're trying to understand how different flavors will interact in temperatures and freezing times and bringing something just under a boil, and what does that do to the taste and flavor of a dish, that's chemistry. So that's preparing you not just for chemical careers, but other opportunities you may have. And it also produces informed citizens. If anything has taught us in these recent days of how important the understanding of chemistry and how it interacts with our bodies and how our chemistry will act with the environment, and how far away we should be or not be from one another, is that we need to have informed citizens like you that will be able to help the others and yourself understand. So those are three great reasons. It understands our world, prepares us for opportunities, whether it's direct or indirect with chemistry, and you're an overall citizen. That's where I want you to be. I don't expect you to remember every single part of every single chemistry lecture, but having at the end of this year, having an appreciation and seeing the world through some chemical eyes, that would be awesome. So we're going to explain our natural world, as we say, help you satisfy your desire to understand how things work, can prepare you for a career, whether you're a programmer, whether you're a lawyer, whether you're going to be a teacher, whether you're going to work at a bank, whether you're going to work in construction, work with your hands, if you're an artist, all chemistry is involved in all of those. And then be an informed citizen to understand how chemicals and decisions around chemicals will affect you personally and in our world as well. You can take an informed action. If anything we've seen today, uninformed actions can be really costly. Really costly. So that's our first lecture. I appreciate you guys listening, and feel free to post questions in the chat that we'll have in the Google Classroom. Thanks a lot.